So Boston housing data is basically a database that is related to housings and in the Boston area and was collected by US government. The main aim or the main problem that this particular data set presents is predicting the sales price given all these various features of that sales means all the various feature of that particular house. So we'll not jump into solving this problem and how machine learning is used to solve this. But for now, we'll use NumPy, Pandas, Seaborn, and Matplotlib to see how this all the various operation that is performed before even considering to model are done. So this includes feature engineering or selection of various feature and drawing insights from the data. So all that is done before even starting with the model. So let's take a look at how all those things are performed using all these libraries. So I have imported Pandas, Seaborn, NumPy, and Matplotlib. What this particular line does is it's not any import statement. It's basically a magic function in Jupyter Notebook. What it does is it represents all the graphs that we will draw, something like this, within the notebook itself, and not means when not a particular window pop-up output kind of thing. So you have to do this so that it recognizes that the graph has internal output. So pandas has this function read csv. Csv is comma separated values. This is the native format in which we will save and will load the data. As you can see, the file is in .csv format. So this particular function read.csv loads the data into the data frame variable df. So yeah, df. So right now, okay. So as you can see, the data is loaded. So if I go ahead and type of df, you can see it's the native type of pandas known as data frame. So it's a data frame object itself. So right now df looks like this. All these columns represent features, and each of these rows represent one particular home or one particular entity. In this particular case, that entity is home. So if you are familiar with the concept of database, you would know you would know these things as attributes, these things as tuple or records. So right now we have 1460 into 81 columns, means we have 81 features and 1460 rows. So just taking a simple look at this, for example, id. So for a home, if I have to decide the price of home, id is not something that I would consider, right? So other than that, something like m members of subclass and everything, ms zoning, lot frontage, all these things are the features that are related to the price of the house, and these things will consider while deciding the price of the house. Some of these features actually do contribute to the change of price, and some of these features might even not contribute to the change of price. So how do we know which features actually are contributing and which features are not contributing? So that is done in data pre-processing, data cleaning, and all those things. So that's why we need data frame and pandas and all the visualization tool of Seaborn, Matplotlib, so that we can actually visualize and understand if the data is needed, if that particular feature is needed, and if they are needed, do we need to make some modification, we need to feature engineer those. So df.head and df.tail, these are two functions. What df.head does is it returns the first five columns, sorry, first five rows of the particular data set. So 0 to 4 are the first five. So this is returning the first five rows. So why do we actually need these two? And df.tail actually returns the last five. Why do we need these two? Is because we sometimes need to look at the data, not the entire data set, but just the particular sample of data set, so that we can take a look and understand what the data set is about and what it represents. Other than this, df.info will return information or metadata. If you are familiar with database, so it will return metadata about the table or about the database. Metadata would include the columns and the number of values in those columns, if they count null or not null, and what type of data is it. So all this information is returned by df.info. So this is needed because for each different type of data, for example, int has different functionality and object may be a string, and something like that, byte stream or anything like that. So that would have a different functionalities, how we'll understand their contribution and what functions we can perform on that particular column. All depends upon what data type is it. Data.describe is basically a function that returns, or method that returns various statistic related to that data: count, mean, standard deviation, minimum, 25 percentile, 50 percentile, 75 percentile. If you're not familiar with these various statistic, let's go ahead and brief about that. Count is just how many number of values are present in that particular column. So if so you would wonder, because it's a data frame of 1460 rows, means 1460 entries are there, each column will contain 1460. That might or might not actually be case in this particular example. For most of the column it's true, but there can be, for example, this here 1201 means a lot of values in this particular column are actually not present, so we might discard this particular column. And even if this column has some contribution, we'll analyze that it has some contribution, and the various records which do not have this feature, will discard those records from the table. So mean is basically an average of whatever values is present. So mean would return whatever average is there for all the numeric column, means integer columns, and other than that float columns. For these two types of columns, this whole data is there. Standard deviation is how much from the mean does the various data points deviate, means from the central point, or from the mean point, how much do we deviate in terms of distance in value. Minimum value of each column, maximum value of each column. So there's not much to describe about minimum and maximum. So 25%, 50%, and 75%. These three are known as percentiles. So what it means to say is how many values in that particular column fall below 25% value of that particular column. For example, if 1460 is the total value, so what would be the 25% of 1460? uh, 0.25 of 1460 is 365, right? So it means that the number of values that will lie below 365. So since this is just id, means it's 1 2 3 4 5 6 and like that. So below 365, obviously 365 values will lie, right? So below 730, 50% means 730. So below 730, 730 values will lie. So below 50% of this columns, 50, means 50 percentile, 50 values lie, 69 values lie. So all these data right now might not seem much of relevance, but when we go to the next module and we'll start with data analysis part, then you'll understand why all this data is actually needed. So pandas actually provide us with various plotting functions itself, like pandas.hist provides us with plotting the histogram part. So as you can see, various histograms can be plotted through pandas.hist, means data frame.hist. And right now we have selected the columns which have integer and float values, because we don't have much use of categorical values like strings and everything. Strings basically represent categories in which one might fall. For example, for a house, what can be the category? Luxurious and average, moderate, priced, and all these things can be categories. So categorical values have a different kind of representation, and numeric values have different kind of representation. So right now we are concerned about the representation which is based on numeric types. So as you can see, I have provided with comments for each of these particular representation and all these things. So there's some thing that is being implied from all these values and everything, all the graphs that is there. So you might go ahead and take a look at that as well. I've put it in the repository. So now going ahead, Seaborn is actually built on Matplotlib only, but it provides you with some advanced feature like kernel density estimation plot. So right now let's not concern ourselves with it, we'll move forward. But yeah, it's good to know that these features are there in Seaborn. So Seaborn also provides with distribution plot. Distribution plot is basically how the data is distributed. For example, the houses that are built over the years. So how many houses were built around 1850? Very few. How many houses were built around 2000? The most. So how many houses were built each year? It provides you with a distribution that when the data was maximum, means when maximum number of houses were built, and when minimum number of houses were built, and data like this you can visualize through distribution plot. So in this particular case, if we go in literature terms, this represents the distribution of houses over the years, or the years they were built in. So yeah. So this is basically how we select the numeric data. So select data types, and which data type do I wanted to select? Integer and float. So 64 basically means we are working on a 64-bit system, so we can means we can actually accommodate a 64-bit value, not something that will cover here. So just know that the data type is int64, float 64. Why we need this data? Because we were going to find the correlation between each of these features. What correlation tells is how two of the features are dependent on each other, how those two features were related. Were they positively related? Positive relation means while one increases, another increases as well. Negatively related means while one decreases, other increases. They have an opposite relation. And how linearly or non-linearly were they related? If the value is 1, that means they were extremely linear, means they were completely or totally linearly related. And if the value is somewhere between -1 to 1, that means there's some relation but not entire relation. So right now, since sales price was our target value that we had to find, so we check for correlation between various columns and the sales price. So between sales price itself, the value is of course 1, because sales price to itself is related completely. That's why if we go ahead and check sales price, relation of sales price with sales price is extremely linear, means it's completely linear, of course, because those two are related, completely related. Now, how do you recognize from this data that some values are categorical? As you can see, for sales price and overall quality, when the quality is this particular value, it has some sales price. For this particular value, it has some sale price. So as you can see, it's not randomly placed, it is in a pattern, means there are as you can see, vertical lines, means all these vertical lines, I can count these vertical lines, right? 1 2 3 4 5 6 7 8 9 and 10. So 10 vertical lines that represent that there are 10 categories. So just judging from the values that are in the x-axis, I can say that it's 1 2 and 3 and till 10. So the overall quality is rated between 1 to 10, and because of this rating, there's a change in sales price over the spectrum. So yeah, so there is some relation between sales price and overall quality of the house, and it's actually a categorical relation. So categorical relation is something where there are categories, which means that there are limited number of divisions that can be made for that particular that particular column or that particular attribute. Similarly, here you can see similar type of representations, same for all these. So all these are categorical values. Other than this, for example, let's take this. So as you can see, the values linearly increase. So this represents a linear representation, means as the value of gr, live area, whatever that is, increases, sales price also increases. Other than that, there can be seen, let's see what else can be seen. This particular value is somewhat exponential, not exponential, logarithmically related. So this one is actually exponentially related, years built and sales price. So means as the years progressed, the sales price grew exponentially. So all these are of different scale and different kind of relation. We'll have to feature engineer all these and bring them to similar scale and similar kind of relation. So this was the insight that was drawn. Other than that, to actually represent the relation, we can use something known as heat map. So as you can see, the heat map has minus point, and means as less the relation, means as less the relation means the correlation is 0, and as much as the relation can be is 1 and -1. In positive direction means completely linearly related, in positive direction is yellow, and completely non linearly related in the negative direction is actually purple. So all these values are linearly related to each other, means they of course are linearly related completely to one another. That's why all the values are 1. So yeah, and other than that, I have filtered the values which have actually higher relations. So the relations which are greater than 0.5 and less than minus 0.5 means higher relation in both direction will only get represented. So you can go ahead and read this and know what this actually means. Regression plot gives you the regression line between two of the whatever attributes are there. So right now this is the regression line and how various values actually fall on that line. So these are the distributed values. Right now regression, let's not concern much about, just know that regression plot is something that we can operate through Seaborn. So yeah, now stepping into categorical data, as we saw that sales condition is categorical value from the above distribution. So yeah, so sales condition has a different distribution like this. Abnormal has this much, ADG adjusted land or something allocated, family, and all these distribution over categories have different values of sales price. So from this graph or any other graph, we draw insight how those are related, means how a particular column relates to the target column that we have to predict. So other than that, box plot is something that is used for categorical values. Different lines in box plot represent different things. For example, all these represent the outliers. This represent the 25 percentile, 50 percentile, and 75 percentile. We'll discuss all these things in the next module. So yeah, this basically covers Seaborn, Matplotlib, their functionalities, and if it was a little fast-paced, I would suggest you go ahead and comment. I will make another video and explain a little more about all these things. But these things, the basic purpose of this video was to explain their functionalities and what all exists there for our use, and not to where to use them right now, just a basic introduction to these things. So I have one another project that I would like you to take a look at. So if you go to my repository and you go ahead and look at the COVID-19, this is a very recent project, not something to be called as project, but just a simple analysis of coronavirus that is currently quite hot. So yeah, you can take a look at that over the data that is actually publicly available by John Hopkins University, and what all operations have I performed, how I have mapped, and correlations, and all the analysis part that is done over there is actually put in text, data by country, data by means data by mean cities and everything, and the comparison between China and India, how China managed to, what we are calling these days, flatten the curve, and when will India actually flatten the curve and all these things. So this is quite old as of now, but I'll update it whenever I get a little time to. So this was around, I guess, by the end of March. I did this by the end of March, so you can take a look just for understanding what all is done. So it's not something fixed in a mold that for everything you will have similar kind of operations. Some operation might overlap, but it entirely depends on data, what data is there, and how the data is to be analyzed. For example, this is a tabular data, so it might have this particular kind of analysis, and even in tabular data, different tables and different data require different kind of analysis, because each column might be numeric, might be categorically numeric, might not be numeric, might not be categorical, might be ordinal. There are a lot of things that we'll discuss in next module. So yeah, the for like that, different data has different representation, different analysis techniques, and all those things. So this particular module basically covered all these things. In the next module, we'll start to delve deep in whatever we understood and might not have understood. We'll understand about different classifications of data, that is categorical, ordinal, numeric, and all these things. Other than that, how data is collected. So we'll be building a web scraper from scratch. All the coding part will be done right in the video, so you'll get to see web scraping from for a recent web scraping project that I did for collecting some data related to stock from yahoo.com, Yahoo Finance. Other than that, EDA, which this project was about, EDA is a technique to analyze everything in one scope. So EDA provides all the data that was discovered here and is discovered here. It's exploratory data analysis. Other than that, how we analyze and clean the data, how we manipulate and rescale, what dimensionality reduction is, and all these things we'll be seeing in the next module. So yeah, this module is covered, so you can go ahead and take a look at the exercise that is there in the module folder, and other than that, you can take a look at a small 3 to 4 page cheat sheet kind of thing for NumPy and these some basic libraries. So we'll meet next week.